Hi, everyone. Today I'll be presenting our work, Reciprocal Teaching, Dynamic Multi-Model Teacher-Student Learning for Multiple Noisy Annotations, or RETINA for short. As datasets grow, expert annotation becomes impractical. Crowdsourcing offers a scalable alternative, but it inevitably introduces noisy labels due to varying expertise. Traditional multi-rater learning methods rely on estimating annotator biases via transition matrices, which have quadratic complexity with respect to classes. This causes overfitting and collapse in hard scenarios. Many classes, few annotators, high noise. Meanwhile, LNL methods show remarkable robustness through sample selection, but they assume a single noisy label per sample, making extension to multi-annotator settings non-trivial. This leads to two key gaps. First, a methodological gap. LNL methods haven't been extended to MRL. Second, a benchmarking gap. Existing datasets don't allow systematic evaluation. We address both. We propose RETINA, an end-to-end reciprocal teacher-student framework that bridges LNL and MRL, and we introduce SYN-MRL, a synthetic benchmark enabling controlled evaluation. RETINA has three components. First, we pair each annotator's labels with a dedicated classifier. No transition matrices needed. Second, at each iteration, we dynamically select a teacher and student model stochastically. Third, the teacher uses LNL based sample selection to divide the student's data into clean and noisy subsets. The student then trains semi supervised. This is flexible. We instantiate it with divide mix, pro mix, and AN. At test time, we average all model predictions. To enable rigorous evaluation, we introduce SIN MRL based on SciFAR 100 with 100 classes. We simulate up to 5 annotators using instance-dependent noise at 30%, 50%, and 70%. Each annotator provides full coverage with different random seeds, allowing systematic variation of both annotator count and noise rate. On SYN-MRL, RETINA consistently outperforms all competing methods. The most telling results are on SciFAR 100 IMIDN70. Many methods collapse. CrowdLayer and GeoCrowdNet fall below 5%. Even a not mix drops to 35% with two annotators. RETINA AN achieves 69%, nearly doubling the best competitor. With 5 annotators, we outperform TraceReg by over 6%. By bypassing transition matrix estimation, RETINA stays robust, where others fail. On real-world datasets, Dopanim, Flickr, LDL, and Chaoyang, RETINA again achieves the highest accuracy across all configurations. Some existing methods perform well on one domain, but fail on others. RETINA remains consistently effective regardless of data domain. To summarize, RETINA bridges L, N, L, and MRL through reciprocal teacher-student learning, and SYN-MRL enables systematic evaluation. Experiments show consistent superiority, especially in challenging settings.